Binary Thoughts. Welcome to another lesson powered by binary-thoughts.net. In this lesson, we're going to cover the data type int. I'm going to cover the basic implementation of ints and walk you through pretty much everything you need to know about ints to start coding in C++. I'm going to start by telling you a little bit about ints themselves. If you don't already know, int stands for integer, which if you remember from math class, an integer is any whole number including negatives and 0, for example 1, 32, negative 27, and so on. Remember, when you declare a data type, it allocates a dedicated amount of memory to support that data type, which means it gives the data type only a certain amount of memory to work with. In C++, an int can hold any integer value as long as it can be stored in the given amount of space in memory. An int takes about 4 bytes of memory, which is enough memory to hold numbers ranging from 2,147,483,647 in the positive or negative direction, which is a pretty big number, and you can pretty much always use ints, but in a lot of cases you do actually have to use data types that hold bigger numbers, such as floats or doubles, and or even a long int. But we'll get on to those a little bit later. So now that we know what ints are, we can start looking at using them. I'm going to refer as ints as integers now from this point, since we've covered that and clarified that for people that didn't know that. And let's just move on to some examples. I've already created a project to show some examples of how to use integers. We'll go through the data type, some basic implementation, and how to use the basic operators, and maybe get into some compound assignments, and just go over the data type and what you can do with it. I've already created my main function, and I got a breakpoint, so when we run the application it won't just close out. I've included the IO stream, and I'm using namespace std just for some of the couts and other display functions I might use. If you watched my data type video or read over some of the material, a lot of this will be review in the beginning, and so just bear with me. But before we can use an integer, we must first declare it and initialize it. And if you remember, to do that, we just type the data type and give it an identifier. I'm just going to give this one number. And let's go ahead and initialize it. I'm just going to give it the value of 0. So we've declared it and initialized it. And if you watched my video, there's several ways that you can declare or declare and initialize in the same step. This is my preferred way of doing it. It's just it's longer and stretched out, but it's a lot more easy for me to understand, at least. Especially when stuff gets more complicated, I can see where it's being initialized and where it's being declared. I guess let's go over some of the basic arithmetic operators. They're pretty easy to understand because they do exactly what you would expect them to do. The plus sign or addition sign does addition. The subtraction sign or dash uses subtraction. The asterisk or star does multiplication. / does division. And the percent sign or the modulus sign, it's what it's referred to in programming, is a really handy one. It gives you the remainder between division. And I'll explain that more once we get to that. But these are your basic operators when using integers. And like I said, they're pretty easy to understand. Let's go ahead and play around with a couple of them. So if we wanted to do some addition, maybe we wanted to know what 122 plus, let's just do 4, which of course is 126. But just for, actually, I think I already got that. Just to prove a point, I guess, let's go ahead and run it and show that it does indeed come out with that calculation. And if you saw that, it does. Number is equal to 126. And if you're not sure what this is, don't worry about it. We'll cover it later. It's just displaying it to console, displaying the actual value of number. And moving on, we can go through all the other operators, but I don't think that's necessary because it's pretty easy to understand what they do. Just like the addition, subtraction would do the same thing, and multiplication would just multiply the two numbers together as expected and give you the output of those numbers. One thing I want to mention about the arithmetic operators is if you're using a series of different calculations, you can do pretty much, I think, an infinite amount of different calculations and so on. C++ will follow the order of operations. So if you were to run this code, it would do 2 times 3 first, and then it would do all the addition and subtraction in the correct order. So it does follow the order of operations. I guess a better example would be 3 plus like 5 divided by 7 or 6 or whatever. It will do the division first and then add the 3 on, just as you would expect in math. And you can use parentheses if you wanted to add 3 plus 5 first and then divide it. So it works exactly like it does in math. Easy to understand. Where it gets a little tricky or misleading is when you're dividing numbers when using integers, because integers only hold whole numbers, but sometimes when you divide, it doesn't always come out to be a whole number. To show some examples of that, let's just do a whole number to start. 10 divided by 5 equals 2, because 5 goes into 10 2 times. And if we run this, we can see that. And it gives us the right value because it's a whole number. But if we were to change this to 11 and rerun this, 5 doesn't go into 11 equally, but it still gives us the value of 2, which isn't correct. Or the way we would expect it isn't correct. It's correct in the way that C++ is designed to work, but it isn't quite the result that we were hoping for, or at least not what I was hoping for when I first started coding in C++. The reason why it gives us the value of 2 is, again, integers can only hold whole numbers. So 5 goes into 11 only 2 times. After that, the rest of the information is lost. And that's where the modulus operator is very handy. It tells us what the remainder is. So if I just change this just to make it easier, and run this again, it will give us the remainder of what is left over after that division, which is 1, which makes sense because 5 goes into 11 2 times, and 5 times 2 is 10, and if you subtract that, 11 minus 10 is indeed 1. So 1 is left over, a remainder of 1. Reason why this is very helpful is sometimes you have to divide numbers, but you want to know if they divide equally, and you can use conditional statements. If number isn't 0, then there obviously is some sort of remainder, stuff like that. So if we were to do this on the first one, 10 modulus 5, we would get the result 0 because there is no remainder. There's no remainder. So, and you can use conditionals, which we'll get into later, of how to set up it to where it will tell if it is equally dividable by certain numbers and so on. That's pretty much all there is to cover on the different types of arithmetic operators. There are different syntaxes on how you can use them. The only ones that I think are important to cover besides the basic operations is plus plus and minus minus, and that looks something like this, or for the subtraction like that. And what that represents is just number plus 1. So ideally it equals the same as number plus 1. So whatever integer is in front of the plus plus, it will reset it to that number plus 1. So it just adds 1 to whatever number represents. And same with the subtraction, it would just be subtraction instead of addition. And you see that a lot when doing loops or some conditional statements. So it's really important to be aware of that notation. A lot of people use it. It means the same thing, but it's just shorthand. And a lot of programmers like to do things shorthand. Makes it it condenses their code a lot more. I still like to write everything out. I really expand my code, and some people argue that that's not the best way to do things. I just really like to see what's actually going on, and it's a lot easier for me to conceptualize. It's kind of a own opinion type of thing, but just be aware of it. There is other notations out there, a lot of weird formats that you can do to add different numbers together, and different ways to do things. You can find more of that on c++.com. I'll put a link on this video and on the website. It's a very good website. I used it a lot when I was learning C++, and it's very easy to understand. That's pretty much all I have to cover in this video. Hopefully it helped. It was really basic. If you've already did some coding, it was probably all review, so sorry if it was, but check out some more videos, make some comments, whatever. Thanks for watching, and this concludes this video.